Let's look at this WeBWorK problem about double and half angle formulas, problem number 10. We are given the cosine of 2 alpha, and we're supposed to figure out the trig functions, sine alpha, cosine alpha, etc. So notice this is alpha, and that's 2 alpha. So we're told that 2 alpha is in quadrant 3. Okay, here's quadrant 3. That means that 2 alpha is between pi and 3 pi over 2. Since we're finding the trig functions at the angle alpha, we need to go over here and divide by 2. So that tells us that alpha is between pi over 2 and 3 pi over 4, so that puts alpha in the second quadrant. So alpha is in this sector here between pi over 2 and 3 pi over 4. So that means that this one's going to be positive, negative, etc. The trick to this problem is to make the substitution theta equals 2 alpha, so alpha equals theta over 2. So I'm going to use the half-angle formula found on page 532 for the sine of theta over 2. So notice I've taken the half-angle formula and copied it down, except I used theta instead of alpha. So this is the same as the half-angle formula stated on page 532, except theta is replacing alpha. So I'm trying to find sine alpha. Remember, theta over 2 is alpha, so sine alpha. I know it's the positive square root because we found out that alpha was in the this angle range here up in the second quadrant, so sine is positive there. And then I'm going into here, so I have a cosine theta, but remember that theta is 2 alpha, so there we go. Because I know cosine of 2 alpha is given to be minus 17 over 81, I can do the arithmetic here and get sine of alpha. You can use the half-angle formula for cosine to get this one, and then instead of using the half-angle formula for tangent, you might as well just take sine over cosine, and then from here it's downhill because these are reciprocals of the ones that you've already found.